differentiate y equals e to the 2x minus 1 power. All right, so in this case, this is a composite function. So that means we're going to need a chain rule here. All right, so let's do a little bit of work on the side, right? So for example, if y equals just e to the x, right? No, nothing else here, right? Then we know what the derivative of this is, right? The derivative of e to the x is just e to the x, okay? But does that mean that the derivative of e to the 2x minus 1 is just e to the 2x minus 1? And the answer is no, right? Because this is a composite function. So, for example, f of x would be the outer function here, which is e to the x. Right? G of x we'll call the inner function, which is 2x minus 1. So f dot g, right, the composite function, would be e to the 2x minus 1. Okay, so how do we find the derivative of composite functions? Okay, there's different ways we can write this, but for exponential functions like this, right, if y equals e to the u, right, so u is whatever that exponent is, then dy dx, we can also call that y prime, right? It's going to be just e to the u itself times du over dx, okay? Which means we have to just take this, but we have to multiply that by the derivative of the exponent here. Okay, so what do we get in this case? Okay, so dy dx in this case, we just take the function as it is, so we get e to the 2x minus 1 times the derivative of 2x minus 1, right? So dy dx of 2x minus 1. Okay, what is the derivative of that? Well, that's just 2, right? So we get e to the 2x minus 1 times 2. Let me just write that in front. Okay, so 2 times that. And there you go, right? This is going to be the derivative here. Now, I'm in the notation. There's different ways to write these things, right? So dy dx or y prime right here. You don't need to put this in here if you don't want to, as long as you remember that by the chain rule, we have to take the derivative of that inner function as well.